Just a quick reminder, if you have not been scanned in and received a raffle ticket, please find Alyssa, who is floating around over there. At the end, we will be drawing a ticket for a raffle. It will be an Echo Spot this time around, so make sure you have your ticket and must be present to win. So we won't come track you down. You've got to find us. We'll get started here in another minute just to make sure that everyone has time to move between sessions. Sorry, I just like to make sure I'm starting on the time. All right, and we're at 11:30. So I will go ahead and get this kicked off because I will probably need all 30 minutes to go through this presentation. Very GIF heavy, very meme heavy. Hopefully it resonates with some of you who are trying to figure out how to navigate the world of containerized applications and usage of containers as a network engineer. So I'll show you some cool little use cases that I have found handy throughout my network automation journey and trying to make sure that I don't have to fight dependencies locally on my machine. But we'll get that as we go through the presentation. So if you haven't gathered by now, this is Docker Containers for Net Engineers. Is it a panacea or a panacea for our problems? My name is Quinn Snyder. I'm a technical advocate with Cisco Learning and Certifications. You can find me on socials at QSnyder. And before I begin, how many folks have heard of either, containers, Docker, containerd.io? Okay, good show of hands. We should have all heard them by now, I would hope. How many have used them in a testing lab construct, whether it be application focused or networking focused? Okay. How many have used them actually in production? Okay. That's about the tail off that I would expect. So we'll dive into this, and this is the agenda. We'll talk about what containers are for those who aren't familiar. We'll talk about what makes them unique and why they're handy to have on tap as a network engineer as opposed to our heavyweight virtual machines and other constructs that we may use. We'll talk about what it means to actually build a container and why some of the order of operations and precedences is important. And then how to make those containers that we've built work for you in a network engineering, network automation context. We're not talking, they will be running applications, but these will be applications that are meant to be used by you as a network engineer to make sure you're not fighting dependency mismatches and versioning and all those kinds of things. We'll have some demo, which will also have a sample code option that you can snag after the presentation. I need to make some updates, so you'll be able to get to the repo, but I'll publish the updates after the presentation, and then we will wrap it all up. So, containers. Everyone's talking about them. Like I said, this is going to be meme heavy. I know it's kind of United States meme heavy, so hopefully it translates, but everyone's talking about containers. And all a container is a running set of packaged libraries and binaries. I emphasize running. For it to be called a container, and I know this is pedantic, but for it to be called a container, it must be instantiated and running. Containers at rest are called images. The reason being, and they're called images, is that they are just existing on your machine, but they have no access to mapped data that may be existing, whether in a Docker volume or whether in a mapped volume across your machine, that may allow that application to run, or it may have other interdependencies in a microservices type construct. We, take our classic 3-tier app. We have web, app, and database. Those connections between those apps don't exist if that image is just sitting there and not running. It's a standardized runtime environment, and it's generally a virtual machine. So if you run Docker or OrbStack or any of the other third-party applications on your laptop, whether that be Windows or Mac, generally it's a lightweight VM under the hood, whether it's HyperKit or on Mac, or on the Windows side, it's either Hyper-V or WSL2. Linux is a little bit different because most of our containerized images are running based on Linux OSs with standard Linux libraries and positions. So generally on a Linux system, we don't have that VM layer. We just have a shim that provides some isolation to some of our critical root file systems and system space. And then we just share those libraries as needed back and forth. So for Mac and Windows, it's a VM to abstract the underlying OS. Linux is not necessarily the case. But again, that's Linux-based. BSD is a little bit different, but I won't go into those details now. And it's also mostly portable, and that's the other advantage. If I build an image on my machine, or I write a Docker file on my machine that will build an image, I can give you that Docker file, or I can give you that Docker image, and you can run it on your laptop mostly. And I'll get to more of that later. And because they're lightweight and they use the shared system libraries, they're generally faster to instantiate than VMs. If we think about even with SSDs and hex core and octa-core Windows machines, or sorry, CPUs, a VM can take 30 seconds a minute to boot up, plus all the, if you've got a lot of dependencies and libraries. Containers can start within seconds. So they're very fast, very portable. We treat them like cattle, not like pets. If we get rid of them, it's not a big deal. Okay, so when we talk about the differences in a kernel and user space standpoint between virtual machines and containers, you'll hear a lot about end space separation and shared fate. So on the right-hand side, as you're looking at it, I have a standard type 1 hypervisor. So think of that as like your ESXi host. We have our hardware, we have our type 1 hypervisor that has access to that hardware and can perform manipulations, but then we have this layer of isolation that separates every abstracted OS from the top of it. That type 1 hypervisor provides an abstraction layer that says, here's the set of hardware that I'm going to mimic or support northbound into my my VMs that are running. Now, there is the potential for emulation of that hardware if you have different VIC cards in your UCS chassis, if you have specific pieces of hardware like GPUs and things like that. We can pass them forward and have the direct access between the two, but there's still that layer of isolation that exists to prevent escaping from a VM into your kernel space. Likewise, the VMs themselves are separated from each other. So if you are accessing in VMA, VMA has no idea or understanding that VMB even exists outside of the things that would pass normally through a network traffic. We've got ARP and other things that'll exist through the vSwitch. But from a hardware and underlying OS perspective, VMA through N have no idea that they exist. They're completely separated. So if A fails, it doesn't matter, B through N will still be running. On the left-hand side, we have what would typically exist within a containerized host. So as opposed to running the type 1 hypervisor, generally you'll have some kind of very thin operating system that runs on top of the hardware. And that operating system is installed bare metal. So that you can run containers on VMs, but generally to get the maximum performance and let the container runtime, whether that's Docker, Podman, Container.io, get maximum benefit from the hardware, you're generally going to run that operating system in a bare metal construct and let the container runtime and all of the container overlays handle moving back and forth. That containerized runtime will then allow you to run specific apps, and I denote app A through N. Those apps exist within running containers, but there is shared fate. So there is the possibility for something that escapes app A to either affect the container runtime, or because of the direct socket access to the kernel space in some instances, something that compromises a container in A may compromise the entire host. So there are some larger security issues that exist in running net containers. Things like Kubernetes help kind of isolate and put some restrictions on that. But as was seen with several Kubernetes flaws I want to say 2021, 2022 timeframe, there were organizations running Kubernetes that were compromised and they never knew it because, and it infected the entire, not just the Kubernetes cluster itself, but the entire infrastructure because of the way they were able to laterally move out due to the shared fate nature. So there is that shared fate. You do need to worry about that. But because we're network engineers, we're not application developers, we can kind of, don't look behind the curtain and do some hand waving and run our apps in a way that makes sense for us, because we're not deploying these to prod, hopefully. So no separation, no problem. It's actually a good thing. Because we have a shared kernel space, we have quick instantiation times. The underlying binaries and system libraries that are running on my Mac in that VM or on my Linux host are already up and active. So all that the container runtime needs to do is say, hey, I have a container that needs these things, spin them up. So it's very, very fast. There's also no department of redundancy department, which means that if I have a heavyweight OS, say I've got 10 installations of Windows, what is it now, 2019, 20, I haven't run Windows in like a decade, but if I've got Windows running in 10 different instances, I have 10 different System32 folders that are all the same thing, more or less. So I've wasted a lot of disk space, I've wasted a lot of hardware, I've wasted a lot of CPU cycles and memory building those things up every single time for every VM. I don't have that with a container because it's all shared. Now, the pedantic person inside of me is going to say, well, if you have a VM, you still are resource bound by the amount of CPU and memory that you assign to your underlying containerized runtime, and that is true. But for the most part, we don't have those same limitations, and there's so much more room for activities. Now, I don't like the fact that this presentation gets recorded because I do have to admit Windows users have one advantage over Mac and Linux users in this one instance. Windows containers are a thing. So if I'm running Windows Core, I can stand up Windows containers that run .NET applications in a container. The key to that is there's no portability. Because of that underlying dependence on the operating system underneath, those Windows containers can only run on Windows hosts. Again, not a huge concern for us as network engineers. I'm not sure we're developing .NET applications for our network automation. But if someone says, hey, I've got this really cool .NET application, why don't you run on your Mac? Like, you got me here, buddy. I will concede defeat on this point and this point only. You win this time. So, any questions so far about the underlying fundamentals of a container? Perfect. Let's talk about building them. Docker files in U. When we build a Docker image, we create an image from defined steps. So we see each of these steps being highlighted by a yellow word. I generally refer to those as verbs. There may be some other documentation that says otherwise or different usage, but I call them verbs because we're running something, we're moving something around, we're changing our directory, we're running a specific application. So I call them verbs. Each of those verbs triggers a specific action. This looks very Windows like sys-ini level stuff from way back in the day, like DOS, where you have very specific or very simple words that you would move. But in this case, I'm going to copy in a requirements.txt file from my underlying operating system into the image. I'm then going to set some environment info. I'm going to run a specific command that changes my bash shell output. I'm going to install some files. I'll change my work directory to my code and then run the bash binary so that when I start the container, I'm already in a bash shell. Each one of those specific words, those verbs, creates a layer. And we'll talk about what the layers look like. But the idea is generally when we build a container, we want that container image to be small. We're not building tens of gigs worth of VMs. We're building a 500 meg container. The reason, or what allows us to do those things is by combining a lot of different actions or similarly grouped actions into a single layer. Now, there are cases where you want to separate those things, maybe from a portability or development standpoint. But in this case, I'm just building a single purpose container. So I am going to separate my two run commands. This is going to do something with my bash RC that sets my terminal prompt. I want that separate from all of my package installation. So I've created 2 steps. We'll create 2 layers, and when we build that container, we'll see the layers lay out in the build process. I've done a bad thing here, and I've shown, for those who are keen of eye, to run Alpine Linux. Back in the olden days of containers, everyone was saying we've got to use Alpine Linux. We have to use it because it's lightweight, it's small, and we can build very small container images that are very portable and very quick to stand up. If you haven't worked with Alpine, I suggest you working with it once, and then you'll realize why it's a bad thing. Alpine comes with its own baggage that if you're not very familiar with how things like Python packages are compiled or how different dependencies are built, it can become very cumbersome very quick, and it creates a larger barrier to entry. So generally, people will have customized Ubuntu images that have some process ID stuff sorted out. We've really gotten past the area where there's a lot of stupid human tricks for containers. You use like a Debian or an Ubuntu container, and you're off the races. It may be a few hundred meg more, but it's not going to make or break the bank here. The other thing is, it's really just all bash. All we're doing is we're creating our bash script and we're tying it inside of a few specific verbs to that Docker file. So for those who are interested in like the DevNet certifications, the Dev Associate and things like that, the reason that bash scripting is covered inside of that certification is because for CI/CD pipelines, if you were in the session before, and Docker files, it's really just bash. The last thing I'll touch on is that order does matter. So when I build these specific images, if I was to do things in a slightly different order, each of those images are squished on top of each other. Think of it as a layer cake. That's the bottom layer, and we move to the top. If I change something down here, I don't have to do a lot of rebuilding and recompilation because I've created all those earlier layers. So a rebuild is very short. If I change something up here, well, all of these layers down here depend on that layer's SHA hash. So if I change a layer that's higher order, like that requirements.txt, maybe I remove it or I change the file name, I have to rebuild the entire container and regather all of those libraries that I built the first time, as opposed to just saying I'm going to slap a new layer on it and call it a day. So are we talking about an engine refresh or a new coat of paint on the car? And because I wanted to put another meme in here, it really is all just bash, and it always has been. It always will be. Bash is not going away. So while, you know, there's some different applicability and use cases, the more bash you learn, the better you're at it, the more all of this will make a little bit more sense. So with that, you've listened to me for about 15 minutes, and you're wondering, okay, get to the point, Quinn. How can we make containers work for us? Well, let's let them do our heavy lifting. How many have written any application or any script that does some network automation in something like Python using NetMiko or Paramiko? How many have done that using Ansible? How many have got caught in Ansible versioning hell where it's like, I've got to have the right collection and I've got to have the right version that ties to my right Python version? It creates a lot of trouble very quickly. And yes, there are applications out there. We can use things like virtual environments to isolate our code between multiple Python builds and our modules and dependencies. We can use tools like PyEnv to allow us to do regression testing across a variety of different Python versions very quickly. But that's very customized. If I'm using PyEnv on my system with a specific set of virtual environments, you don't have those on your system. So for me to give you an Ansible playbook on a specific version of Ansible with a specific set of collections running on a specific Python version, you have to do all of that work and install it on your local host. That is not very portable. If you're working in a very small team, maybe you can kind of have a working session to get everyone on the same page, but even then, things can go wrong. If we compile everything into a container, if we let our container images exist with all of our binaries, with all of our dependencies, with all of our collections, with all of the correct versioning, we now have portability between users. All I have to do is make sure that I've mapped the correct folder if we're sharing code snippets between your system and your container. You just have to make sure you have the right folder mapped, but other than that, everything else is the same across multiple users. The best part about it is maybe you fat finger a Python command and you completely destroy your modules or your versioning. All you got to do is stop the container and restart it, and you're right back to where you were. So we don't have to lose time troubleshooting a broken Python installation. We just kill the container and restart it. Again, cattle, not pets. And this makes sure that we don't have to do any more stupid human tricks. They're more convenient than VMs, and we can use other stupid human tricks to interact with them. And I knew I could make this work. So for those who are not old neckbeards like myself, who have been in Linux land for a while, GNU Make was kind of the de facto standard for building C and C++ applications because of the way that we could have staged builds, triggers, pre-checks, post-checks, but it was really for that C and C++ programming. So if you have, back in the early days when you're installing from source, you'd move into a folder and do /configure, make, and make install to move a compiled binary from source into your directory in your path. We're not doing that here, but we're using make files to make the process of building and running containers much easier. And again, I'll give you samples of this after the end of the presentation. But if you're really, really, really bored, you can go to the GNU.org website and look at the entire Makefile book. It's like 500 pages. I guarantee you, if you have trouble sleeping, that solves your problem right there. It is a very handy utility. Don't get me wrong, but in the era of Python and Go, not a whole lot of people use GNU Make anymore. So the demo, you can hit that QR code and that will take you to my GitHub repository. It's also Cisco U 2010. Don't worry that the numbers don't align. I ran this in Las Vegas earlier this year, and the Cisco U numbering did not translate between one to the other. So you are in the correct session. This is 1812. The folder is 2010. So before I jump into that, oops, I can actually leave this running. Any questions so far? I'll leave that up so you can snap that. It also helps you can take a picture and then you can reference it later. Any questions so far? Yes, sir. Oh, you're talking about being able to run Windows containers? There are fixes and there are patches that are constantly being put into upbound, Docker and northbound containerized.io. It's something that we have to be concerned about from an application development perspective because we have that shared fate. And to extrapolate on that a little bit more before I jump to the demo, there are things that allow direct memory access to hardware in VMs, things like SRIOV, DPDK. We start using hardware counters and things directly off the CPU, but those are specifically coded into things like VMware and Hyper-V to allow us to do that. If we don't have those things that are available, they're not exposed northbound. So there are fixes that are available. The difference being is ESXi has a very specific hardware compatibility list where they can guarantee that operating, whereas I can run containerd.io on anything from Raspberry 0 all the way to a really beefy, 128 core UCS server. So there's a lot of differences that can't be accounted for because it's an open source software. So we'll dive into the code here. So what I'm going to do here real quickly is we'll go with a basic Docker file. So I'll look at this as, that's Python. Let's go to the Ansible one. This is just a Docker file that I have built. We're pulling from a container that I built earlier. I'm showing this one because it's a lot simpler. We'll jump into the Python one a little bit later. I have 4 different containers that I've built: Ansible 2.9, Ansible 2.10, Python 3.7, and Python 3.10. The 2.9 Ansible is running on the old version of Python. The 2.10 version of Ansible is running on the new version of Python. And we'll see that in the Docker files. I'm pulling from an existing container. I'm changing my shell here. I'm copying a requirements.txt, installing that with pip, gathering some Ansible collections to be able to interact with iOS XE and NXOS devices, and then I'm changing into a specific directory and running bash so I have a shell in that container. We can see that this Ansible 2.10 is coming from Python 3.10. Our Ansible 2.9 looks very similar, but I'm coming from Python 3.7. And there's a few different collections that are installed because of the differences in versioning and things like that. The Python Docker images that I've created, you can actually pull these Docker files directly from Docker Hub. So Docker or hub.docker.com/Python, and you can gather the Docker files directly from the Docker website. There's a lot of stuff that goes in here. We're building Python from source, so it does take a while. And then all I've done at the very end here is change a few things to make sure that my shells look very similar, and I'm changing some code in there and things like that. And I will show one other thing here. This is my make file. So I'm doing some really ugly things with my make file, so don't take this as a make file class at all. But I'm saying use a bash shell. I have these targets what are called phonies, which means don't worry if there's still files that exist in those folders. Just run them as I say them. Just run my bash script. And again, because we cannot escape bash, even my GNU files are referencing bash scripts or bash commands. So all I'm doing is as I'm creating some aliases to say build Python 3.7, build Python 3.10, build Ansible 2.9 or 2.10. Here's the Docker command that you're going to run to make that happen. So I don't have to remember that long string of information. I've just put it there so I remember one thing and I'm good to go. Same with actually running the containers. And this is where it gets really difficult sometimes to run a container. Because you do a Docker run. Sometimes you need privilege mode. Sometimes you don't. Sometimes you need interactive. Sometimes you don't. Maybe I have some terminal settings that I want to make sure there. In this case, 256 colors, so we get a nice colorful shell. The most important part here is I've mapped this directory. I've mapped this current directory, Python 3.7, into root my code. Now, if you remember from the Docker file itself, that my code folder is where we're working from. So I have the directory that I'm currently in mapped directly to the my code folder. So I have code that's being shared between my container and my host system. Let's see here. And I just duplicated that same thing for each of my different containers. Now, I am going to quickly kick this off. If I do a make build Ansible 2.10, for example, I've already pre-built this, so we don't have to worry about time constraints here. It's already been built because I've done it before, but you can see we've done some work here, but we can see we've got layers, 1 of 6, 2, 3, 4, 5, 6. Each of those numbers corresponds directly to the verb that I created in the Docker file. There were 6 major action steps. So each one of these creates a layer. Those layers get exported to an image. We flatten them all out, and we have our we have a workable image that we can now instantiate using our Docker runtime. So if I do a make Ansible 2.10, for example, hit enter, we see the shell command that it executes as part of that make file. I'm now in a container that matches that PS1 that I set in the Docker container itself. I'm in Ansible 2.10 in a folder called my code. If I do an ls-l, I can see I have some folder structure, so the requirements.txt in the Docker file that I used to build that, but I also have an Ansible folder. If I do an Ansible version, we can see that I'm running 2.10. If I do a Python version, we're running on 3.10.11. So just what I created in my Docker file is what is running in this container. Now, just to show that there's nothing up my sleeve, I have, let's go to cd Ansible. I have this 99test.yaml, and I'll just cat this real quick so you can see what's going on. I'm just doing a fact-finding mission. I'm going to gather IOSXE facts and NXOS facts from 2 always-on devices in the Cisco DevNet sandbox. I'm going to run this Ansible playbook 99test.yaml, and we'll just have some minor verbosity. This is going to run. You can see I'm running Ansible version 2.10. It's going to go out. It's going to gather the facts from both. Oh, I might not have saved that. Yeah, that one is up. There's a problem with the sandbox that's under maintenance on the IOSXE side. So this will work. I just need to wait for that to untime. But it will come up. We see we are gathering the facts out of our NXOS device. So we can see that Ansible is in fact working. The reason I have done this is I now have a portable Docker image that I can either export from my host system or give the Docker file to someone on my team and say, this will work for our automation processes with the correct Ansible version. It has the correct collection. All we have to do is build new playbooks and run them using this container. The best part is, once I hit exit, I am no longer in that container. I'll do a Docker PS just to show. No running image. So I now have a portable development environment for all of my network automation completely contained in that container. And if we go to Ansible 2.10, we can see that mimics exactly the folder structure that existed on my local system. So I'm sharing files between the two. So that's how you can make Docker containers work for you as a network engineer starting your network automation journey. Any questions? Yes. I'm sorry? Yes, yeah. Correct. And yes. The question was, I created two different containers, Ansible and Python, or sorry, two different versions of each, two Ansible, two Python. There is a link dependency. Yes, and the follow-up was, you can put the Ansible stuff directly in that Python container if you wanted to. Absolutely. The reason that I separated that is there may be instances where I don't want any of that Ansible baggage. I wanted to have a clean Python container that I could do other things with. Maybe I'm doing some actual development with NetMiko or things like that. I don't want Ansible pylib SSH conflicting with NetMiko. So I separated them in that way. That's more of a process thing than anything. But yes, you can shove everything in one massive container if you wanted to. Okay. So I'll leave this demo up. Please complete your surveys. There should be for the Cisco U session. And if you have any questions, I will be around the rest of the afternoon. Back around here, they're doing scanning or back in the demo. And because you were also patient in waiting for me and listening to my voice drone on for 30 minutes, we'll now hold the raffle for the Echo Spot. And because I don't trust Alyssa, I'm going to mix all these up really, really well. And ticket ending in 6475. 6475. All right, we have a winner. Thank you so much, everybody. Like I said, if you have any questions, all this code will be up here. I will update it. There's a few tweaks I had to make overnight for the sandboxes because of updated versions. But yeah, that will contain everything that I used to build my demo here. Thank you.